Alright guys, it's Mr. Lynch. We're coming at you with a new video for lesson 2.1a. We've gone into a new unit. This is awesome. This is one of my favorite units that we're going to do. The additive inverse. So we're working with integers, so positive and negative numbers, to create what's called zero pairs. Now, a zero pair means that we're taking something and we're either adding or subtracting the opposite amount to get to zero. They undo each other. So, like if I have 5 minus 5, well, that equals 0, right? Anything minus itself equals 0. So, we can say that 5 plus negative 5 equals 0. So 5 and negative 5 are opposites. They undo each other. I mean, I could take this all the way up to 20. So 20 plus negative 20 is going to be 0. All right, that's a zero pair. It's two numbers that add up to 0. And that means that they have to be the opposite. So one is a positive and one is a negative. So we're going to work through some of these problems with you guys, looking at finding how many zero pairs we have. So first one, context, a hydrogen atom has one proton and one electron. So this is really cool because this does apply to science. So if we have one proton, which is positively charged, and one electron, which is negatively charged, 1 minus 1 gets us a 0 charge. So it's a neutral charge. And we have one zero pair because there's one of each of these. So now looking at number 2, I took 4 steps forward, and then I turned around and took 3 steps back. So these undo each other, these undo each other, and these ones undo each other, meaning we're left right here 1 step ahead of where we started, and we had 3 zero pairs. So if I got a check in the mail for $1 million, I would love to get a check in the mail for $1 million. That would be great. But then I got a bill that says I owe $1 million. So, I got this check for $1 million, then all of a sudden, the IRS says I didn't do my taxes right, and they're going to charge me $1 million. Well, okay, that's nice. So we have 1 million coming in, so going into our bank account, but then we have 1 million coming out. So if we have 1 million going in and then 1 million coming out, that's like taking 1 step forward to take 1 step back. We're right where we started. So we have the same amount of money as before. We have the same money as before. So how many zero pairs do we have here? Well, technically, if we're counting it by single dollars, we have 1 million. But if we're counting it as just a check for $1 million and a bill for $1 million, we have 1 zero pair. But I'm going to write 1 million here because I want to think of it as dollars. So that's like you go to the store and you buy a candy bar for $2. Well, you decide that's not the candy bar you wanted, so you return it and you get your $2 back. So Joe found 4 quarters, but he had a hole in his pocket and lost one of them. So we get 4 quarters. We have 4 quarters coming in, but then we have 1 quarter coming out. And as we can see, that's a zero pair there. So we have 1 zero pair, and we're 75 cents richer because we have 75 cents that we actually still have. Now, if Lisa earned $8 and then spent 6 of those, where are we at? All right, so let's go $1, $2, $3, $4, $5, $6, $7, $8. So we earned $8. And I draw these arrows just to help myself to see which way everything's going. And then we spent $6. 1, 2, 3, 4, 5, 6. So $6 going out. Well, let's match these up. So we have 1, 2, 3, 4, 5, 6. We have 6 0 pairs here because we earned this dollar and then spent that dollar. Earned this dollar and spent that dollar. Earned, spent, earned, spent, earned, spent, and then spent. So we really saved $2. And I really like drawing this line to separate my 0 pairs from what I have left. It really helps me see what's going on. Okay, so then John took $15 out of his bank and then decided to deposit $10. So I'm going to draw 15 circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oops, 10. We don't need 11, we just need 10. Okay, so these are coming in. Actually, I got that backwards, guys. Sorry. Undo. So if he took $15 out of his bank, we have $10 here, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5. Okay. So they worded this problem kind of funny, didn't they? They worded it a little bit different than the rest that we've seen. So if we took $15 out of the bank and then deposited 10, we have $10 going into the bank, and we have 15 coming out of our bank. Okay, so how many 0 pairs are there? Well, there's 1 going in and going out, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's $10 that are going in, or that are going out just to go back in. So I'm going to draw my line right here so we can see that we still have 1, 2, 3, 4, 5. So we have $5 that we took out and kept with us. So how many 0 pairs do we have here? Well, we have 10 0 pairs, and we have $5 with us. And sorry, I meant to write up here, we have $2 left. So guys, I know this is kind of a hard concept. I know this can be really difficult to look at, but I know you guys can do this. Okay. So in the following exercise, we're going to use this key. So white squares are 1, and shaded squares are -1. We're going to look at the models and think about what they could represent. So in number 9, I'm going to say this represents 8. Why? We have 8 1 squares. Right? We have 8 positive 1 squares. Okay, so looking at 10, I'm going to say this is -8, because we have 8 -1 squares. And guys, this is really cool because this is what you guys are going to see next year in math. All right? We use the same modeling to look at linear equations, and we'll throw some more stuff in, but it's exactly the same stuff. It's really, really cool. Number 11. Okay, so we have 1 positive 1 and 1 -1. I'm going to say that this is 0. This represents 0. Why? We have 1 1 square, and we have 1 -1 square. And if we add 1 to -1, so if we go 1 minus 1, we get 0. So now let's look at 13. 13, we have 2 1 squares. And guys, it's perfectly okay to do your argument before you say what it represents. All right? So we have 2 1 squares, and we have 3 -1 squares. Okay. Well, that means we're going to have 2 minus 3. Oh man, how do we do this, guys? How do we do 2 minus 3? Well, here's the way that my brain thinks about this. All right, you guys want to know how my brain thinks about this? So in my head, when I see 2 minus 3, I'm going to write this off to the side here so I can show you this work. I look at these, and I say, okay, which one's bigger? Is our first number bigger, or is our number we're subtracting bigger? Which of these is bigger? I'm going to say that 3 is the bigger number here. And so if the bigger number is the one that we're subtracting, I'm going to rewrite this with a negative out in front, because I know it has to be a negative number. Because if we go forward 2 spaces, and I'll draw out a number line here. Here's 0, 1, 2, negative 1, negative 2. So 0, 1, 2, negative 1, negative 2. So what this is saying is that we start here at 2. This is where we started. Or we started at 0, and we went forward to 2. Well, now that we're at 2, we have to go back 3 spaces. So we're going to go back 1, 2, 3 spaces. Well, if we go back 3 spaces, we're going to be in the negative. So I'm going to put that negative right out front. And then I'm going to put some parentheses here. And I'm going to change the way this looks. I'm going to do the opposite of what it says. So if it says 2 minus 3, I'm going to write 3 minus 2. Well, that's easy. I know what 3 minus 2 is. That's just 1. So our answer to 2 minus 3 is negative 1. Because we bring that negative down and we write in the answer to this problem here. Now, this is the way my brain thinks about it, guys. All right? And it does help, but because everybody thinks differently, it may not help everybody. Okay? What could help most of you guys is this here. All right? This is what we're going to use a lot of. We're going to use number lines to help us. So if we move forward by this amount here, and then if we see a negative sign, we're going to turn around and go backwards that amount. Okay? These are the 2 ways that we're really going to be doing this in this unit.